Welcome to qnawire.
In this problem, we're told that we have these neutron stars that are spinning at a very high rate of speed, at 70.4 radians per second. That's going around very fast. And we notice there's a little blip, and all of a sudden it changes. Its angular velocity changes, and that percent change, or that fraction of a change is 2.01 times 10 to the minus sixth. So that would be what, 2.01 times 10 to the minus fourth percent. So a very small change. And we're told that it initially has a radius of 11 kilometers. And so they ask us, well, they think that what's happening here is that the crust of the neutron star gets kind of compacted, and so the neutron star's radius got a little smaller, which caused this angular velocity to go up, because again there'd be a conservation of angular momentum, because there's no net torque going to be acting on this neutron star. So conservation of angular momentum says, if we assume the neutron star is a uniform sphere, that then initial angular momentum, final angular momentum, basically tells us that the ratio of the radii squared equals the inverse of the ratio of the angular velocities. So we have omega naught, and then we can divide omega 1 is just omega naught plus delta omega. So we can plug that all in. And we know delta omega is this times omega naught. So omega naughts cancel out here. And so we get R equals 1 over 1 plus 2.01 times 10 to the minus 6 to the 1/2 times R naught. And that gives us, this thing here is very, very close to 1. And so we get a value of R1 of, this 10.99998895. And so they ask us what is the change in a radius. So we can subtract this from this, and we get about 1.1 centimeters. So it compacted about 1.1 centimeters. Now, in reality here, we got to start questioning significant digits. How close? I guess we can probably measure this fairly accurately, because we're measuring like pulses from something. So the frequency of the pulses we could probably measure fairly accurately. But again, I would say it would be a lot better to just say what is the ratio of the radii change here, because to say that, if we only know this to 11 kilometers, so the two significant digits, well, that means that two significant digits, this is just 11 kilometers too. So I don't think it's a very good problem, in the fact that we have significant digit issues. It would probably be better to just say what is ratio R1 over R1 over R naught, or delta R1 or delta R over R naught, and that would be R1 over R naught minus 1. So we could just look for this guy here, and from this ratio here, and again that's going to be a very small percentage, just because this is a very small, delta omega was a very small percentage of omega naught.